In this video lecture, I will discuss different types of functions. So first one is one-to-one function, or we also call it injective function. So what is one-to-one function? If there is a function f from set A to set B, so that is called as one-to-one function or injective function. If for every B belongs to B, there exists at most one A belongs to A. Or in other words, we can also say that a function is one function or injective function if every element of set A is having a unique image in set B. Okay, so that is called as one-to-one function. So that means more than two elements cannot have the same image in B. So that means obviously every element of B, there exists at most one A only in set A. Or a function is injective if these conditions satisfy. Means if A1 is not equal to A2, that means FA1 is not equal to FA2. Means if, for example, I'll take this example. So suppose f is a function from natural number to natural number, n to n is a set of natural number, and my function is 5x. So if I take x value as suppose 1, so f1 will be what? 5 into 1. Okay, now if I take f2, so 2 will be 5 2. So 1 is having only one image. Image of 1 is what? 5. Image of 2 is 10. So every element of first set is having a unique element in set B. It's not like one is having two different elements. If I say 1 and 2, so 1 and 2 are having two different images. It's not like 1 and 2 are having same images. So if f1 is coming 5 here, f2 is coming 10, f3 is coming 15, f4 is coming 20. So every element of A is having a unique image in B. So this condition also, if A1 is not equal to A2, means if 1 is not equal to 2, so obviously F1 is not equal to F2. So that is one-to-one condition. Now second function, this if I say fx is equal to x square, so fx is equal to x square, so fx is equal to x square. Okay, here it is x square, it is not x2. If I say fx is equal to x square is injective, and where x is a function, from z to z, where z is what? Set of positive integer. Z is set of positive integer, so I can only take positive values here. So if I take 1, here is 1 only. If I take 2, so 2 will be 4. So every element of first set is having a unique image in set B, because I can only take positive numbers here. But in the third example here, because f is a function on set of natural number, so here fx is equal to x square, what will happen? Because it will contain positive as well as negative both. So here if I say minus x square is also x square. So if I take f1, that will also come 1, f minus 1, that will also come 1, means two elements are having same image. So that is not one-to-one function. So that's why 2 will be an injective function, whereas 3 will not be an injective function. Now second type of function is many-to-one function. Many-to-one function means many elements of A are having same image in B. So in this example we can see here 1 and 2, they are different elements and they are having same image 0 in B. So this is called as many-to-one function. Now what is onto or surjective function? So onto function means, see, if I told in the beginning of the function video, for a relation to be a function, there are two conditions. Each element of A should be associated with some element of B, and it is every element, one element, each element of first set A cannot have more than two images, but two different elements can have the same image. Okay, so here if I'm saying every element of A should be associated with some element of B, but it is not necessary that all the elements of set B should also be associated with some element of A. But in onto function, that is the condition. Every element of B should also be associated with some element of A. So we can also say that the image of F equal to its range. So range means the element of B that is associated with some element of A, or we can also say the elements of B that are image of some element of A. So in case if it is only function, it is not necessary that all the elements will be associated with some element of A. So that range, if I talk about, it may not cover the entire set B. But if I say every element of B should also be associated with some element of A, that means the range will cover the entire set B. So that's why the image of F equal to its range. Okay. Now if I take this example, f is a function on set of positive integer, then fx is equal to x square. So basically if I can only take positive integer, I take f1, so f1 it will come, f2 it will come 4. So if I say here, if I take any element, suppose if I take 1 2 3 1 2 4 set of all positive number, so every element will be having some pre-image in first set. So that is onto function also. Now one-to-one correspondence is what? It is also called as bijective function. So one-to-one correspondence if it is both injective and surjective. So injective and surjective both. So if I take this example, fx is equal to 2x minus 1, is it bijective function? So that means if I want to prove that it's a bijective function, means we have to prove that it is both injective and surjective. So for injective, what is the condition? Fx1 is equal to fx2, then I should be able to prove that x1 is equal to x2. Means if I am saying two elements are having same image, okay, so that means both the elements should be equal. That is the condition of one-to-one function. So if I say fx1 is equal to fx2, means for any two different element x1 and x2, then here I will substitute in place of x, I'll substitute x1 and x2. So fx1, it will be 2x1 minus 3 is equal to 2x2 minus 3. So this means from this I can say that x1 is equal to x2 when this will be same when x1 is equal to x2. Now it is injective. Now for bijective means every element of B, means for each B belongs to capital B, means for every element of set B we should have some A in A. So here if f is a function that is 2x minus 3, so suppose this is equal to y. So what is the value of x? I can tell x is equal to y plus 5 by 3. So that means which belongs to what? So this this x value means for every y there should be some x. So this x value, whatever value I will get, that will always belong to R because it's a function on set of real number. So that means it is surjective also. So it is injective and surjective both. So we can say it is one-to-one function or a bijective function. Then next is invertible function. So what is invertible function? If I say f is a function from A to B and it is invertible, that means the inverse function should be a function from B to A. So if I say this, if take this example, if there is a function f from set A to B and these are the elements of set A, B, C, D, and these are the images of these elements, so fa1, fp, fc, ft, and so here f inverse should be a function from B to A. So this elements of B are this and A, B, C, D. So this that means if I am saying invertible, so f is a function from A to B, so I should be able to prove that f inverse should be a function from B to A. So all the condition of function should be satisfied. Okay, then next is identity element. A function is said to be identity function when f of A is equal to A. Means if I say f of 1, I should get 1 itself, f of 2, I should get 2 itself. So the image of the element should be the element itself. So that is called as identity function. Now what is constant function? Means the image of every element of A is having some constant value, so some fixed constant value. So f of A is equal to C for each A belongs to domain of F. So where C is a fixed element of A, means if I say I have here some A, B, C, D, here some fixed elements, so all are having the same image, that fixed value only. So f of A is equal to C for each A. Okay, now what is into function? So into function means if f is a function from A to B, so it is called as into function if there exists some small b in B which is not image of any A in A. Means if I say here I have A, B, C, D, so A, B, C, D, so here and here also I have 4 elements, so some 3 are associated with A, but at least some elements of B are not associated with A. Suppose this FD is not the image of any element. Suppose this D also, image of D also this FC only. Okay, so then FDs will not be associated with any element of A. So at least some B in B, it should be some small b in set capital B, so which is not the image of any of A. Then we will say that it is into function. So that's all about types of function. Next class we will discuss composition of function. Thank you.